divided by E. This was the formula for the chi-square goodness of it. So whenever you are going to add a frequency here, frequency here, and frequency here, so it will become the formula of the test for the independence. So as you can see, so instead of O, we have mentioned here INJ. You can see at the bottom that I stands for the individual score. Clear? So as you can see, we have already discussed that this will be called as a dependent variable for our study, and this will be called as independent variable. And if independent variable, we have a multiple category like A, B, and C, and under the dependent we have a more than 3 category. So table will be called as 3 into 3, uh, 3 into 3, 9 contingency table. So what we are doing here, we are calculating a total of rows and total of columns. Total of rows, that means A plus B plus C we have got here, D plus E plus F we have got here, H, G and I we have got here. Clear? Then A, D, G at bottom. Like this we have to see, we have to do the sum in this direction and at this direction also, both the sides, and this will be called as a grand total or grand, and this we can calculate. So at what cases we are going to apply this particular uh, example called the test for independence, and what was the difference between goodness of fit and test for independence? The first difference is the difference in the degree of freedom. In goodness of fit, we are taking a degree of freedom as a n minus 1. We are taking degree of freedom as a n minus 1. But for the test for independence, we are taking, because we have two different things. We have a rows and we have a column. So R minus 1 is representing to row minus 1, and C minus 1 is representing to column. So from the total value of row and from the total value of column, we are going to reduce minus 1. So that is the degree of freedom for the chi-square test for independence. And like this numerical you are going to get in the examination. For example, in US, there is a two political party like we have in India, two major political party, Congress and BJP, and government or people want to find out that who is going to win and what was the opinion poll by the general public of US, that they have taken a survey of around 500 participants. So N will be called as 500. So 500 US adult were asked about the political affiliation and opinion upon the tax reform. There was some bill which was going to be placed in the assembly, that what was the view of the citizen or view of the population, those who are staying in the US, that either the tax reform should be implemented or not. So they have done a survey, and what was the result of survey? They have found how they are going to code their results. Two political party was there. The first was Democrat and second was Republican. Clear? And three options they have given to choose. These were the three options. One was in favor, indifferent, and the oppose. So those who are in favor and belongs to party Democrat, they were 138. So this table, what you are seeing right now, this table will be called as 3 by 2 table is equal to 6. That means we have a 6 value. So this we are not going to bother total, and this we are not going to bother total. We are going to look for the these value which are there in the circle. So in chi-square, what we used to do, we have to identify the maximum proportion, so that we can say that maximum people are saying this thing. Clear? So as you can see, the size of the table is 2 by 3. It's not 3 by 4. You cannot count total as a separate category. So total should be omitted out, and you should consider this table as a 2 by 3. So because there are only 2 rows, where the party affiliation data is there, and under the three columns we have a opinion of the population, that in terms of favor, indifferent, or the oppose. So as you can see, how to proceed with the test. For the goodness of fit test, the expected frequency for each category is obtained by how we are going to calculate the expected frequency. Here you can see that expected frequency we have calculated E by taking the average, that average of the observed. Clear? Like the same way, we will calculate the FE, called expected frequency, which will be equivalent to the this Pn. Now, what is that P? P is the proportion from the null hypothesis, and n is the sample size of the sample. So, how much is the sample size? Sample size is 500. Clear? So, by using the formula, we can calculate the formula for test for independence. I have written here that this one. This is the formula. The x square is equal to sum of I and j. I represent to independent value. For example, each value. For example, I can say that this A is I, or B is I, or this C is the I. So what we have to do for the test for independence, the expected frequency for each cell in the matrix is obtained by this formula. See, in the previous test, what we did, goodness of fit, we have taken a average as a expected frequency or the expected value. But here we have to calculate the expected value, and how we are going to calculate the expected value, that total of row we have to do and total of column divided by n. This is going to give us a expected frequency, and the observed value will be taken as all the 9 values, whatever is the 9 values are there. For example, like this we have to write. I'm going to write one value will be called 138, second value will be called 83, third will be called 64, then again 64, 67, like this we have to write in a row. So this value will be considered as a value of observed. Expected we have to calculate by using this formula, that means total of row and total of column. And how to do the total of row and column? You have to make a contingency table like this, and by using a contingency table you can do the total of row like this, like A plus B plus C, it is going to give you, then D plus E plus F you can get here, then G plus H plus I. So in this way also you have to work like this, and from top to bottom for the total of column you are going to get. So column total you are going to get, and row total you are going to get. So both value can be put here and divided by n, which was the 500, you are going to get a expected frequency. And once we have an expected frequency, you can calculate the chi-square and chi-square value, and that chi-square value is compared with the chi-square table, which is I have shown you in the previous class, that this is the only snapshot of chi-square where I'm getting my degree of freedom. For example, here my degree of freedom for the goodness of fit test was found to be 4. So I have to look for these value. Now I have not discussed yesterday this table which is shown here, what it means. And every time I used to say that confidence interval of the study is 95%, and uncertainty level or the margin of error is 5%. And in I think the day 3rd or day 4th, I got a query that why we have got this one 0.05 and why we are not using any other value. So this is we used to call sets for the statistical analysis. Like whenever we are taking 95% of confidence interval, we used to say that we are highly confident to quote our hypothesis that A is causing B. That A is causing B. How much we are confident? to say this thing, to state this hypothesis that A is causing B, if you're taking 95% of confidence interval, we say that we are highly confident. But still, we are expecting a margin of error that is equivalent to 5%. If we take confidence interval of 99%, our term changes. We will come to very confident, and there that time margin of error will remain 1%. So cutoff point of the study is going to change. It will become 0.01. I can write here something, for example, 96. It will become 4, and here I can write 0.04. If I write 97 here, it will become 3, and it will become, cutoff point will become 0.03. On the same way, this is the one where clinical trials will be conducted. That means that time the scientists were extremely confident to quote that A is causing B. All of the clinical trials will be conducted at the confidence interval of 99.9%. So what margin of error they are expecting, or we can say that what was the uncertainty level, that will be 0.01, and for them p value will be this much. So whatever the row we are seeing here, on the chi-square table, we are seeing two different rows. So first row is representing to this one, highly confident, and second row is representing to very confident. We will have another row here, which I have not taken, that will let us know about the extremely confident. For example, if our chi-square value or the t-score value or f-score value, which we are going to compare with the tabulated value, is less than or more than whatever the test says, test standard says, we have to compare. That is very based upon test to test. We have to match that value. Clear? For example, here our score was found to be 4.14. So this 4.14 I have compared with two values. One value was 9.4 and second value was 13.4. So as you can see that we do not reject the null hypothesis because 4.4 is less than 9.4. कि 9.4 से 4.4 कम है, and this 4.4 is also less as compared to 13.27. So whenever we are not able to reject null hypothesis at higher level, so obviously it has been rejected automatically at the lower level. So there is some chances that might be at this level at 0.01 your hypothesis will be not rejected, but at 0.05 it will be rejected. So you are going to get a multiple example in the statistics where you are going to find a different cases where based upon the 99% of confidence interval, you are going to find that test results are not significant. But if you change the confidence interval of your study from 99 to 95, and you'll find that your results are significant. So sometime what we used to do, we used to apply the statistical test, and after that we will see that how much confidence interval of the study we should take if you want to work smarter. But you cannot do that in your study. For one statistical test you can keep confidence interval of 96, and for another statistical test you can keep confidence interval of 95. For the whole over the study, for the whole of your PhD project or whole over your master thesis project, confidence interval of the study will remain similar. Once only you have to quote in the introduction of your thesis, whenever you have discussed the sample size calculation, or you are going to discuss that how sample size was calculated. So these both figures, that 95 and 5, you are going to add in the sample size calculation. So I think tomorrow or day after tomorrow I'm going to take a session on sample size calculation, that how we are going to calculate the sample size for the various studies. We will take the help of two different software called AppInfo and RawSoft, and by manually also we will take 2 or 3 different example, like for proportions how we are going to calculate the sample size, and for the observational study which are most common used by the researcher, so how to calculate the sample size for those studies also. So by 4 or 5 different methods, we will try to calculate the sample size, and each type, whenever I'll calculate the sample size, for example, for the proportions or for the observation studies, I have to use some sort of figures. So most common figures are N, capital N, that what was the population size. Second, for example, you are conducting a survey. So while conducting a survey, where you want to conduct, you are to conduct in Delhi, you are to conduct in Bombay, you want to conduct in Goa, where? So what was the population size in that particular area? That will be considered as capital N. So that number of N we are going to as in the sample size. What will be the confidence interval of the study you are expecting? 95, 96, 97. This figure also we are going to use in the calculation of sample size. What is the margin of error we are expecting? Margin of error also figure also we are going to use, that 5% error we are expecting. And one more figure will be there, expected frequency, EF, which we are discussing in the chi-square test. Now EF stands here what? EF stands here as a expected frequency, that as per researcher. For example, I will let you know in the simple term, I want to conduct a small study in my college. That in my college around 5,000 students are there. So I want to find out that out of 5,000 students, how many students are suffering from diabetes. Clear? So while calculating, so I cannot go to one by one student, all the 5,000 students, to and ask them that what was your fasting blood sugar, and I cannot monitor the fasting blood sugar of 5,000 students in my college. So what I'll do, I will calculate the sample size. That means from each class or from each course, I have to take few number of samples. So what was the design I am taking, or I'm choosing to take the student from the different courses or from the different classes? That will be called as a study design. So based upon the study design, formula for the sample size is different. For example, I will let you know in a simple language. For example, I need a space to write. Yeah, this one. Assume that 5,000 students are there in my college, and I want to conduct a study on diabetes mellitus. I want to find out that how many students are suffering from diabetes. I cannot go to all the students one by one and ask for the fasting blood sugar of individual students. So what I'll do, I have to calculate the SS. So this SS will be considered as small n, whereas this 5,000 number of students which those who are studying in a college will be considered as capital N. So capital N will be called as population size, and this SS will be called as a small size. This SS I have to calculate. So what are the different options? That, for example, I have chosen a one formula by referring a research paper, and in my research paper I found that by doing a calculation of 5,000, the sample size was found to be 230. Clear? So this is the number which I have calculated. So out of this 5,000, I have to take 230 student which will participate in my study. Now who will be 230? Because in my college I have a different courses. I have a PhD program, I have a MPharm in 9 different branches, masters in 9 different branches. We have a UG course, we have a diploma, right? And we have a other certificate course, like this. So for example, 1, 2, 3, 4, 5, 6, 6 different courses are there, and MPharm is 9 different branches. So total 15 courses are there, and still we have a 2 different kind of population, 15 courses, male and female. So I have to choose a one particular design, by which mean it is not necessary that I should take all 230 students from this course only or from this course only. Then study will be called as biased. This 230 participant should belongs to all the courses. Clear? And it should contain both type of population, that male also and female also. So I have to choose a particular design, like from each class I'll take 5% of students, or from each class I'll take those students who have gained a first to 10th rank in the university. Some sort of criteria I have to make. So what I'll do, yeah, or we will can choose a criteria the day we are going to take the sample. So the students who will come in the class first, that we choose. So if we set a particular criteria, so that will be called as a different type of sampling. If we are not bothered that, okay, any person, for example, in PhD program I have 100 students. So out of this 100, which one I'm going to take? For example, I have to take only 20 out of 100. So which 20 out of 100? So if we have certain criteria, so type of study design will be different. And if I'll say that any 20 out of 100, for example, the day I'm going to take a sample size or the sample from the PhD candidate, so whoever will meet me first, that will be enrolled in the study. So that will be called as random sampling. Randomly, I have taken any 20 students from the 100. So study design is very important, and based upon the study design, this we are going to discuss in the further classes, that what are the options we have for the study design. For example, we have a snowball study design, we have a stratified, we have a cluster, we have a random sampling, we have a simple random sampling. Like this, multiple study designs are there, and we are going to see the classification and chart of that. So based upon study design, sample size formula will be chosen, and based on the sample size we will define that what was the confidence interval of our study. So all things are linked with each other. So whenever, if you have done a mistake in one of the step in the research, your whole project is going to be deviated. We'll go to the topic which we are discussing. Yes, this one today. uh, as I told you in chi-square goodness of fit and chi-square test for independence, manual calculation we have two different formulas, but in SPSS we have only one method for the chi-square to apply, and this was the pictures which I have shown you yesterday. Click on analyze, go to descriptive statistics and cross tab. Just we remember that cross tab is the command by which mean we should apply the chi-square test, and we are not bothered about row and column, that which variable will be kept where. You can keep any variable where. And when once you click on statistics, and under the statistics you are going to get the option for the chi-square test. This is the option which you are seeing inside the circle. So whenever you will choose this option, and I have also discussed that what was the mistake made by the student. Most of the time they will not click on row, and yesterday I've shown you the data that if you not click on row, so what kind of data you are going to get in the output sheet of SPSS result. We need the percentage in terms of proportions to show the highest proportion whenever we are comparing two different categories. So for that, highest value will be taken, and that will be quoted in the result, like I have quoted here. And this is the formula, this is the way how we are going to write. For example, you have applied a chi-square test in your thesis, then you can add this cross tabulation table, you can add this table for chi-square, and if you're writing the result in a research paper, then both tables are not recommended. You should write only one paragraph, this one, that A is compared with B, A is compared with B, and maximum proportion was found how much, that you are going to write in the bracket percentage, and write with whom you have compared, that you found highest proportion in the obese group as compared to normal and overweight. So you are going to discuss about the overweight and the normal also. That means Highest proportion was observed in obese as compared to normal and overweight. And this is the MLA writing style. I want to show one presentation to you. For that, I have to shut down this one. I'm going to stop the this presentation, and I'm going to show you another one, that how different presentation is going to help you for your research work, for writing, especially when, for example, you have applied a statistical test and now you're ready to write the results. So how we are going to fill the tables, that which data we should take from the table. So for that, I have made a few presentations. So those I'm going to discuss with you all, guys. Let me share my whole screen. Let me share my whole screen so that you will be able to see that what I'm doing. Yes, I have a few presentation. Might be you're able to see this one, then all these which I have selected, and this one. Each presentation belongs to a particular test. For example, this one I have made for One Way ANOVA. This one I have made for independent t-test. This one I made for linear regression. This one I made for paired sample t-test. This one for the multiple regression model. This one for splitted ANOVA. So I'll just open any one of them. For example, I'll open for ANOVA. So how you are going to report this? I'm not going to take in the all classes. I'm just going to send this presentation to you guys so that you can refer afterwards. For example, you have applied One Way ANOVA, which we have done in last to last class. So what are the different writing styles of ANOVA? So you can quote the result of your own work by referring this particular presentation. So the format which I have used to write the results in the APA format, that is American Psychological Association. So you are going to get multiple presentation online, that how to write the result of ANOVA in APA or in MLA. So both formatting style are accepted by most of the journals. But whenever you are going to publish a research paper in a particular journal, you have to go for the journal's guidelines, author guidelines, and there they have mentioned exactly that you should write your result in terms of MLA or in terms of APA. Now, what we used to do, we will never bother all these things. So whenever we will communicate a research paper, we used to get back, or without reviewing. They will even never send your paper for review without the reviewer's comment. The editor or the senior editor is going to send your paper back, said by quoting that your paper is not matching with the scope of our journal, or we have lots of publication in the queue, so it's better you to send your paper to some another journal, something like that. Okay, they will never say that you have not made the manuscript as per our guidelines. If only few addition was there, then obviously the editor will ask you to change. For example, if a referencing style is different, or there is a modification in 5 or 6 references, they will ask you to change. But if whole manuscript is not as per the journal's guidelines, then they will send you back. Now, why they used to send back? Because they are not, whenever they are going to make a paper, yeah, uh, whenever they are drafting your manuscript in their software, for example, they are not working on MS Office, they are working on latex software called latex. And if your manuscript has been made as per journal's guidelines, they have to work very you can say very early they can make your manuscript. Otherwise they have to work a lot in the latex software to convert your manuscript, or to convert your result from MS Office Word to the latex. So a particular software will be used, so that most of the journals require you to send manuscript as per their own guidelines. So this presentation is going to help you for writing the results. That means you cannot write that B was compared with A. It has been mentioned already that whenever you are quoting your hypothesis, you have to write first the name of the independent variable. Then only you can write the name of the dependent variable afterwards. You cannot write that B is caused by A. You have to write that A is causing B. So that was just only example I was quoting. And you can see on the presentation what I've written. This is the writing style. You have to quote that a one-way ANOVA was conducted. Now, instead of conducted, you have another option. You can write performed. Most of the researchers are writing conducted, but there is a chance that if all person are using the same format, so there will be chances to get your paper plagiarized. Clear? So what you can do, you don't have to write one-way ANOVA. You can write one-way analysis of variance. You can write, or you can write a test to compare more than two category. A test to compare more than two category was conducted. Or you can write one-way ANOVA. So there are different styles. The meaning will remain same. So first of all, you have to introduce the test, that which one you have applied, to compare the effect of. Now name of the independent variable you have to write here on dependent variable. For example, our independent variable is A. That one way ANOVA was conducted to compare the effect of A on B. So this was the first line which you are going to write. Second, this is the example. I have taken one example also, that one way ANOVA was conducted to compare the effect of type of athletes on the number of slices of pizza eaten in one sitting. That means in Olympics or in any games, there are different type of athletes are there, and we want to find out that what type of athletes can consume how many slices of pizza in one sitting. Is there a difference, or all the athletes, those who are participating in a relay race, or those who are participating in the javelin throw, or those who are participating in the boxing, all having the equal number for consuming pizza in a single setting, or there is a difference? This we want to find out. So how you can write that one way ANOVA was conducted to compare the type of athletes. Type of athlete, that means we have a more than two categories. More than two categories are there, then only we are eligible for the ANOVA on the number of slices. Now why I have written mention number here, because dependent variable should be given in terms of number, and data of dependent variable should be normally distributed. So one thing, it is clear that dependent variable is given in the form of number and data is normally distributed, and independent variable is having a more than 1, 2, and 3 categories, or 4 or 5. It should be more than 2 this side. So like this you can quote the introduction of your test. This is the way that these are the example, that type of athlete where football player, basketball player, volleyball player, soccer player, etc. Either they will eat a number of slices of pizza in a single setting are equivalent or different. So null hypothesis says what? Null hypothesis says that all the athletes will consume equal number of slices. What you have to do? You have to reject the null hypothesis for your result to be significant. That no, there is a difference in the type of athletes. Now reporting style. This is the blank format. So once you have received the test results by SPSS, you are going to write this blank line, and you have to fill few things under these lines where I have not written anything. That analysis of variance shows that the effect of now independent variable, effect of independent variable on dependent variable was significant or not significant. There you will have two different options. Clear? So here you write type of athlete and number of slice of pizza was found to be significant. F is the sign for ANOVA. Here we are going to get a degree of freedom value 2 or anything. On ANOVA table you are going to get a two values or degree of freedom, one for total and one for within. So within value will be written here and total value will be written here. And after that, F score which you are going to get will be added here, and the P value will be added here. I'll show you in the by marking so that it will be easy for you to understand. Yes. So what we have to do, we have to fill the blanks. Now, a analysis of variance shows that the effect of, now I have filled type of athlete on number of pizza slices eaten was found significant. Now we have to fill this value. This table you are going to get in terms of ANOVA. Clear? And on ANOVA, what you are going to get, see, degree of freedom we have got this two. You are going to add between groups. 2 you are going to add here. Then 66, this one is the degree of freedom within, which you are going to get. So 2 and 66 will be added here. And after that, you have to add a F score, whatever you have got. And you can see the value will be given in 3 digits, 99.818 after decimal. So I'll just take only 2, 9.82. So even I have converted is 99.81. And after that I have 8. So I have omitted this 8, but I have converted this 1 of 81 into 2. So what's the rule of converting value? Whenever any value which is above 0.5, you are going to convert. For example, I have got here 8. If it was less than 5, then I will not convert. If it is more than 6, 7, 8 or 9, any value having these 4 digits, 6, 7, 8, 9, then I will take a higher value. Instead of 81, I'll take 82. If it is 5, 4, 3, 2, 1, then I will take it 81 only. I'm talking about third digit after decimal, 0.000. I'm talking about this third digit. If third digit is 1, 2, 3, 4, 5, then we'll not change the value. If third digit is 6, 7, 8, 9, we'll take the higher number, 1 plus. So P value will be quoted, and we in SPSS we are going to get like this, that 0.000. It is very difficult for the software to display the value after 3 decimal or 4 decimal. So we should convert, we should make it 0.001. I have not done here, but it should be made it 0.001. And whenever you are going to write this P value, it should be written in italic. You should write like this: P is equal to 0.001. So once all the blanks has been fulfilled, you will have a final answer. So this is the final answer, that a analysis, this you are going to quote in the research paper. See, whenever you are writing thesis, then all table of descriptive statistics and this ANOVA table you can add in your thesis. But for writing a research paper, no need to add table, because you are limited to table and the characters, number of words, because the whole manuscript should be written in 3500 words or 4000 words. So what you'll do, you will just add these three lines. That a analysis of variance shows that the effect of type of athlete on number of pizza slices eaten was significant, comma, f in the bracket 2 and 66 bracket close is equal to 99.82. This is the value of f. This is the value of f. P value, you should make it 1. Degree of freedom within, degree of freedom between and within. And this is the writing style of APA. Here you have quoted that results are found significant. This is your independent variable type of athlete, and this is your number of slice of pizza dependent variable. So like this presentation I'm going to share when we are near to finish all the topics of our module. Then all the presentation I'm going to send you guys so that you can refer all these presentation. For example, you have applied a linear regression, or you have applied any statistical test, so that how to write the results of a particular test, you don't have to bother directly by using a any presentation. You can find out. For example, this is for the independent t-test. You can see the example that you can write: an independent sample t-test was conducted to compare, now dependent variable name, because independent variable might be there will be one condition or two conditions, both you can include. And independent variable you can write in the blanks. One example I'll let you know that you can see that a single sample t-test was conducted to compare the truck driver drowsiness score for the country music listening and the no country music listening conditions. That means you are finding out a score. So score will be given, taken as a dependent variable, and obviously it will be given in the form of number. So dependent variable will become what? The dependent variable will become the drowsiness score, which is given in the form of number, and it is normally distributed. And you have two different category for the drivers: those who are listening music and those who are not listening music. Like in gender we are having male and female, because for independent t-test we require two categories, and data should be normally distributed for the drowsiness score. So like this you have to fill level 1, level 2, you are going to find out. And this is the blank style, how you are going to write the result, that there was a significant or a not significant difference in the score between the independent variable. Here you are going to quote the mean and standard deviation. And if you want to quote a mean and standard deviation in APA format, we used to write like this. Still you are going to find that a mean has been written something like 22.7 and plus minus 2.3. So this is very old style, we are not referring this nowadays. All the mean and standard deviation should be written in this form. And this is the t statistics blanks. So here you are going to add something, here you are going to add something, p value you are going to write here. So this presentation will be given to you, and from what table you are going to add what value you are going to see by referring this particular presentation. That means equality of variance test you are going to find here. This is the results of t distribution, sorry, independent t test as SPSS output sheet. And from here which value will be kept where, you can see by referring this one. So finally how the result will be written. Last slide is showing you the format of writing the result in a one paragraph, one line or two lines. That, for example, if you want to find out that what was the writing style of independent t-test, you can see here that there was a significant difference in truck driver drowsiness score, what we are trying to find out. So we have to write that thing first. For country music listening, score was found 4.2, SD 1.3, and for the non-country music listening, score was found 2.2 and SD 0.84, and test score was found to be this much. T is the sign, then 8, 2.89 is the test value, this is the degree of freedom, and p value, whatever you have code, you can write here. What are the thing which is missing here? The mean difference. Mean difference was not discussed. So mean difference, whatever you have got it in the previous slide, that this is the mean difference value, the 2.8, sorry, yeah, 2.8. No, not 2.8. Yeah, this is the mean difference, the 2.0, because the first group is mean was got 4.2, second group mean was found 2.2, so difference was 2.0. So this mean difference was not quoted in the last paragraph which I've shown you. So you can write here also that mean difference between both the type of music listening was found to be 2.0. This I'm going to send you guys after few lectures when we are near to finish all the sessions. Let's come to my own topic today, which I supposed to take or supposed to finish. We are getting delay, so yeah, the I think presentation is visible. Yeah, the first test which I was taking, and for that I'm going to use a dataset 2.3. So dataset which I have already sent you, there you are going to find a SPSS file with the name 2.3, and the test which I'm going to apply on the data which I'm going to show you today, this one, this data set, that data has, we have a ID, we have a type of clinic, we have a type of label, and the time. This will do. I'll take another half an hour for that. So another test after the chi-square, we have a alternative of independent sample t-test called as Mann-Whitney U. So whenever we are testing the difference of numeric variable between the groups, we are comparing the mean when the distribution is normal. If distribution is not normal, for that case we cannot compare the mean, because mean will be considered when you have a bell-shaped curve, when all the three measurement of central tendency, mean, median, and mode are meeting at a single point. Clear? When all the three values, all the three measurement of central tendency have a different values, that means mean is having a different value. You have a data set, and if you are going to calculate the mean, median, and mode of that data set, and you are going to get different values for mean, median, and mode, you're not longer to switch with a parametric test. By showing mean is not recommended in the research. For that case, what we have to do, we have to go to the alternative. We can code our result in terms of median for the data where the distribution was found skewed, or distribution of data was having a skewness. Either you have a positive like this graph, or you have a negative skewness like this graph. So in that case, data will be quoted in terms of median. Clear? So this we have already studied. So we should use the another alternative as a median for the skewed data. But the test, whatever the difference is significant or not, we should compare the ranks. So data will be represented. For example, I have applied a test called Mann-Whitney U. So as I have already discussed, for the all parametric test, we are not going to get a descriptive statistics. We are going to get only single value that result were significant or not significant. For example, when I have applied ANOVA, or when I have applied a uh, one sample t-test or independent sample t-test, paired sample t-test, we have got the first table called descriptive statistics, in which mean, standard deviation, and n was quoted. On the same way, for the non-parametric test, we are not going to get the descriptive statistics. If we want, we can generate with the help of SPSS software, but test is not going to provide you. Test is just going to give you a direction that null hypothesis was rejected or it was not rejected by just quoting a p-value. What it means, I will let you know by using an example or by using a dataset 2.3. For example, a study on waiting time in minutes. I will let you know the situation first. We have a clinic, for example, and in that clinic, we have a 3 or 4 multi-specialist doctors sitting. Those who are looking for the patients in a OPD, outpatient department. So the management of the hospital, the management of the hospital want to know that which doctor is earning more for hospital point of view. If doctor is giving more time to see a patient, then obviously the number of patient who is going to visit a particular doctor will be less, then charges will be quoted by the hospital will be less. So they want to find out that in different departments, doctor are having the time to check the individual patient is the similar or different. Or second point of view, you can say that a patient is there, a patient is visiting to the hospital and he's asking to the receptionist that how much I have to wait to visit a doctor. Do you have a some sort of data that I have to wait at least 5 minutes or I have to wait at least 10 minutes? So to find out the waiting time, that if one patient is already sitting in the chamber of doctor, so how much time will be taken by another next patient to visit again? So this we can calculate by using a test. That means we want to study a waiting time in minutes amongst 80 patients. So n for the sample was found to be 80. N of our study is 80 who attended outpatient clinic, which is divided into two parts. That means hospital is having a two different ward. One was medical ward and second is surgical ward, surgical unit. But still this medical is further divided into based on the specialty: primary, specialist, and tertiary. That means I will draw what the study design says. We have a hospital. In the hospital, we have a two different department: medical ward and surgical ward. And these all medical and surgical is further divided into three units: primary care, specialty, and tertiary. This one also primary care, specialty, and tertiary. So whenever, for example, you want to compare this with this with waiting time, so it means test will be two categorical and one numerical. Waiting time you are going to get in minutes, so data will be 2 minutes, 3 minutes, 5 minutes, 6 minutes, 7 minutes, like this. So data will be available in the form of number, that is numerical data. And when you have checked the distribution of this data, it was not found not normally distributed. We got skewness in the data for this waiting time. So to compare, when we are comparing with only medical and surgical ward with this waiting time, then the test will be Mann-Whitney U Mann-Whitney U test. And if category are increased, for example, based upon the different settings, we have a primary care, specialty, and tertiary. Three category are there under each. Three here, three here. So whenever we are comparing with the category with the waiting time, then the test will be different, because here we are comparing with three categories: primary, specialist, and tertiary. Then the test will be alternative of ANOVA, called Kruskal-Wallis test. Kruskal-Wallis test. So in a simple term, I can say that Mann-Whitney test can be applied for two categories, and Kruskal-Wallis test can be applied for a data having more than two category, for example, 3, 4, 5, or 6. And Mann-Whitney U is the alternative of independent t-test, whereas the Kruskal-Wallis test is the alternative of ANOVA. So here you can see that when I have checked the waiting time of distribution of waiting time, I didn't get bell-shaped curve. That maximum patient is having a waiting time of between 10 to 30, maximum range 10 to 25 something. But still we have found a patient who's having a waiting time of 90 minutes also. So because of this 90-minute and this 70-minute, we have found that data is not normally distributed. Clear? And you can see how the data will be written. Data are skewed to the right, that we have got a positive skewness or right skewness. This side, if we have got data here, then we'll say it is negative, with a mean of 25.3 minutes and median of 23. Data ranging from 10 minutes to 84 minutes. Minimum was 10 and maximum was 84. This is called descriptive statistics of the data of waiting time, if you want to find out. Now, so whenever uh, we are comparing median, or we are applying a Mann-Whitney U test, or we are applying a Kruskal-Wallis test, actually what we are comparing? Actually, whenever we have applied a student t-test, independent or ANOVA, we were comparing mean. But in case of non-parametric test, we are comparing a ranks. Now, ranks here means what? Rank are the data that are placed according to the groups from smallest value to the highest value. Whatever the data will be given by the examiner, you have to arrange that data from lower order to higher order, I can say in ascending order. And the value which will be written, or which will be placed at the middle of each group, will be considered as rank. For example, we have a data set of A and data set of B. 10, 20, 20, 30, 40 of A, and 10, 20, 30, 30 and 50 of B. So I'll take 2 from this side, 2 from this side, total 5 are there. So actually what we are doing, we are comparing this 20 with 30. So it will be considered as we are comparing a rank. So what we are comparing this 20 with a 30. So to make a module for comparing the ranks, you have to arrange the data from smallest value to the highest in the ascending order, and data which is written at the center will be considered as rank. So see, this you can find when your data is in even, and if data will be given uh, by examiner, it will be given, for example, in terms of odd, that instead of 5 value, if we have a 6 values, we have a 60 here and 60 here, then what will be the center? So what we'll do, we'll add 0 at first, then again will this will remain 20, and 30 will remain as a center point. So always we need a data to find out the center. We need a data in terms of 5, 7, 9, 11, 13, 15. Then only you can get the center point. So for that you can add 0 at the starting. So compare to independent non-parametric sample test we used to call as Mann-Whitney U test, which is the alternative of T independent T test, where the data was found normally distributed. And the situation is the same, that we wish to compare the waiting time, which is not normally distributed. That means what we did, we have applied the test for the normality distribution to the waiting time to find out the normality, and we found that waiting time was found not normally distributed. We got the positive or right skewness in the data, so we have chosen that we will go for the Mann-Whitney U. If the waiting time was found normally distributed, then we should go for the test called independent T test, because we have only two categories, medical and the surgical. So what is that? Mann-Whitney U test is a non-parametric test that can be used in place of an unpaired T test. Now, why I have called unpaired? Because there is no correlation between medical and surgical ward. Both ward are independent. The readings which you have taken from medical ward is separate, and reading which you have taken for surgical ward is separate. Both are not from the similar patients. The person who is going to medical ward is not going to surgical, or the person those who is going to surgical ward is not going to medical ward. Both are independent, so these are unpaired. So to test, we have to see the null hypothesis for two samples. So actually what we are doing, we will compare the median with the help of ranks. We are comparing the median with the help of ranks. So null hypothesis for Mann-Whitney U says we have two different groups. One group is called as X, and second group will be called as Y. Clear? And you can see this is the null hypothesis. The Mann-Whitney U test is based on a comparison of every observation, xi. That means if we have a 5 different observations like this, 10, 20, 20, 30, 40. So we are going to consider each and every individual sample in our study. Clear? The total number of pair-wise comparison that can be made is nx and yn. So first group will be called as X, second group will be called as Y. Like we have a two groups in our example. One is our surgical ward and second one is our medical ward. So we can say that our reading will be NS or NY, that number of patients who is going to surgical ward or number of patients who is going to medical ward. So probability is what? Whenever the patient is coming to hospital, we are not knowing that which department he want to visit. So chances of going into medical ward and chances of visiting surgical ward is half, is equal for a patient. If it is 3 units, then it will be 33.3. He can go to medical, he can go to surgical, and he can go to the orthopedic department. But in this case, the chances of going the patient into medical ward and to surgical ward is 50-50%. So probability will consider as half, and that will be considered as greater or smaller than the yj. Now what is that yj? J is the difference, I'll let you know. So Null hypothesis says what? Null hypothesis says that probability of individual of X is more than Y equivalent to half under the null hypothesis. And opposite of that, and not equivalent to half, will be considered under the alternative hypothesis. So what we have to do, we have to reject this. In statistics, this slide I have shown you yesterday also, that Mann-Whitney U test is a statistical equivalent to the Wilcoxon rank sum test when we have a distribution or not. So to illustrate what we will do, we will apply this particular test by both the way, manually as well as with the help of SPSS. And I'll let you know that sign of Mann-Whitney U will be considered as U. So two different methods are there, that in, for example, if manually we want to calculate the Mann-Whitney U, so we have still two options. Option number one, with the help of these numericals, that means by using the equations for the Mann-Whitney U. Mann-Whitney U was the name of the scientist who have developed the test, and according to his formula we can proceed. And one more is their method, that will be called as by the method of magnitude. So what I'll recommend to all my students, that go for a method of magnitude, because we don't have to remember the equation whenever we are going to calculate the Mann-Whitney U test with the help of magnitude or by the root of magnitude. We don't have to remember any sort of equation directly. Just we have to remember the number of steps, and we have to use some techniques by which mean directly we can calculate. The second method is by equation. These are the equation, that two different groups are there. One group is medical, second group is surgical, or one group is X, second group is Y. So for both we have a different formula. This one you can see. Now forget about that medical and surgical ward, because that example I'll take in the SPSS whenever I'll run the test. How to do it with the magnitude rule, I'll let you know. We count the number of times in X from the sample 1 is greater than the Y from the sample 2. That means, like, what we have to do, what the meaning of these two lines, I will let you know by the help of this example. In the exam, students are going to get a numerical of Mann-Whitney U like this. That means the examiner is going to give you a data of two different categories, like they have given two different categories. One is male and second is female. So here student used to get confused. When two category was given, then which test to be applied? They have an option for independent test. They have an option for Mann-Whitney U, which we are performing right now. They have an option for the paired sample t-test, where two categories are there. So between these three tests, student will be confused or researcher will be confused that which is the best suited. Shall I go for independent? Shall I go for Mann-Whitney U, or shall I go for paired sample t-test? How to recognize? This is the main which I'm going to teach. If examiner have discussed about normality, if he will write that the following data shows that age at diagnosis of type 2 diabetes in young adults is the age at diagnosis different for male or female. That means he has given the data of two different categories, male and female, and they want to find out that at what age people suffering from diabetes. is similar for male or similar for female, or there is a difference between the gender. Clear? So that different ages of male has been given and different ages of female has been given, but here they have not discussed about normality. So this is a confusing situation. Here you cannot identify that either I should go for parametric or either I should go for non-parametric until unless the examiner will not write that the following data is normally distributed or not normally distributed. He should write on the numerical itself only. The data which he has shown in for males or females is distributed or not normally distributed. If distributed, go for independent t-test. If not, then go for non-parametric test, Mann-Whitney U. And if you'll write, if both for data set A and B are different and he has written like pre or post or before or after, then obviously you are going towards the paired sample t-test. There also we have a two different category. So here you have to see if it is written male and female, then this theory will be rejected, that it's not paired sample. For paired sample, on the top or the name of the variable will be, for example, A or A naught, X or X naught, pre or post, before or after. Then it will be paired sample. If they have quoted that both are different groups, that this group is is different and this group is different, then you have only two alternative, either independent t-test or either go for Mann-Whitney U. Out of these two, anyone you can choose. So if distribution is normal, go for Mann-Whitney U. If distribution not normal, go for Mann-Whitney U. If they have not mentioned about distribution, then what to do? Then arrange the data in this order, lower order, higher order. Okay, and write, or you can own make in graph. Right here 10, 11, 12, 13, 14, 15, 16. Then write where X or Y was plotted, sample number 1, 2, 3, 4 or 5, like this you can write. These are the number of patients, 1, 2, 3, 4, 5. These are the age of the patient, and you can see patient number 1 is having age 11, so you'll mark here. This is 11, you mark here. Patient number 2 is 12, you'll mark here. Patient number 3 is 16, 16 will be somewhere here. So like this you have to mark, and when you will draw all the data points, you make them and try to find out the distribution. If you find that you're getting a bell-shaped curve, assume it's a parametric test and you have to apply the independent t-test. If you're not getting bell-shaped curve, then go for Mann-Whitney U. So for that, what you have to do, you have to plot this graph your own to check the distribution. So only see, examiner is going to give you only 10 or 15 reading, so it will not take that much time to find out the dots. That, for example, if you want to draw a dot for 19 and this is the patient number 6, so you have to find out that where is 6. 6 will be somewhere here, and like this you are going to find 19 is here. So for 19 and 6 you are going to plot a dot here, somewhere here. So like this, draw all the plots and connect the lines and try to find out the distribution. So once it has been cleared, okay, now I have to apply t-distribution or I have to apply the Mann-Whitney U, you can proceed. And you can see that how to proceed the Mann-Whitney U. This numerical I'm going to take, then remaining all these things we'll see in the tomorrow's class. This I'm going to take today. As you can see, it was not mentioned that data was normally distributed or not. And for example, by seeing a graph, we have found that it was not normally distributed, and we have chosen that we'll go for Mann-Whitney U. So for Mann-Whitney U, as I told you, we have two different methods, with equation, without equation. This one which you are seeing on the screen is the without equation, and we used to call in the order of magnitude. In the order of magnitude. How to do it? Just remember the rules which I am going to suggest. Rule number 1, mix both the categories, male and female. Arrange in the order of magnitude, that means lowest to highest. This 11 is representing to this 11, this 12 is this 12, 16 is this 16, this 17 is this 17, 19, then 20, 22, 24, and 29. Fine. As you know, we had two different categories. So what we have to do, first write the exact category, that this 11 belongs to what? 11 belongs to female. So we'll write F at the bottom. That we'll write 11, we'll mark a line, and after that we have a 12 and we have a 16. So we have arranged from lower order to higher order. Then we'll write either they are male or female. This 11 belongs to a female, so I'll write F. This 12 belongs to again female, I'll write F. This 16 belongs to male, this one, I'll write male. So identify the group, either male or female. This was first. Now here the order of magnitude works. How many? Now you have to see the opposite group. That means how many males are there which is less than that particular value. That means this is a female, 11 is a female. Now you have to look for a male who is less than 11, and we can see no male is there who is less than 11, so I'll write 0. I'm writing for male, and like this you can write for the female also. So whenever you are writing for female, you write on top, and whenever you're writing for male, you can write the opposite group at this line, like this two line will be drawn. So any 12 is a female. So what we'll do, we'll look for the male less than 12. No one is there, we'll write 0. Come to third, 16 is a male. Any female less than 16, yes, we have a 2. One is 11 and one is 12. So we'll write 2. So like this, we have to follow the opposite group, that how many numbers are there under the opposite group and less than that particular value. If we get the answer, we are going to get a answer for this and answer for this one. That means we have got how many males are there less than female and how many females are there less than male. You're going to get. And what you have to do, you have to do the sum of this one and sum of this one. Sum of this was found to be 3, and sum of 2 plus 3 plus 4 plus 4 plus 4, it was found 17. So you can say the value of Mann-Whitney U for male and value of Mann-Whitney U for female was found to be 17 and 3. Clear? So out of these two value, the value which is less will be considered as a final value of U. So if you want to calculate the final value of U, so what you'll do, you'll see that out of these two, which one is the less? 3 is less than 17. So 3 will be considered as a final value of U. So you can see here I have done the same. Here I have done the same. Okay, I have taken the sum of these here and sum of 0, 0, 1 and 2. Here, two value has been calculated, 17 and 3. So U minimum we have to calculate, and U minimum will be considered as a value, final value of U. So U minimum was found to be 3. So we'll consider U as a 3. So this 3 we have to take to a Mann-Whitney U distribution table. And from there we have to find out that either we have got the null hypothesis rejected or accepted, our results are significant or not significant. For a two side, I will show you that where is the t distribution table. This is the two Mann-Whitney U table, and you can see now we have to see one more thing, that how many numbers are there under that, what was the sample size of male and what was the sample size of female. Sample size of male was found 1 2 3 4 5, and female it was 1 2 3 4. So 4 and 5 was there. That means n1 and n2 we used to call the value of n1 and the n2. So like the same you can follow that value of n1 is 5 here. The value of n1, the first group, is 5, and value of second group was 4. So this is 4. So at a alpha level of 0.05, the score was found to be 1. Clear? So this 1 we have to compare with the U3 which we have calculated. This one we are going to compare with the value of 3 which we have calculated. So what was the test score? This we'll discuss when we'll do the second numerical of Mann-Whitney U with the help of this equation, that U1 is equal to R1 minus N1 in the bracket N1 plus 1 divided by 2. So this is the formula. See, you can consider the formula for Mann-Whitney U as this one, or you can consider as a this one. So when even you can consider like U3, then you have to write R3 minus N3 in the bracket N3 plus 1 divided by 2. So this is not going to change, it will remain same. So either you can go for this or this. This will take tomorrow and we'll try to do the numerical. So method is the same. Actually, whatever the equation we have got, we have to use, we have to find out the final value of U. And here also, for as you can see that two groups are there, so 2 times we'll calculate. One time we have got final value 184, and second time we have got a final value 56, and which will be considered as less value, that will be considered as U minimum. So as you can see that 184 and 56 is the less as compared to 184. So final U value will be considered as 56. So this 56 will be compared with the value which is given on the table, and for that we have to find out that what was the sample size of n1 and what was the sample size of n2. So this numerical which you are seeing on the screen right now, but method is different, that how to calculate this one. For that we are not using the method of magnitude, because in magnitude we don't require any equation. Directly we have to arrange the data from lower order to higher order, write the groups and look for the opposite, how many numbers are there, and you are going to get a value for first group and the second group, and from both the groups the value which is having a lower number, that value will be considered as a value of U minimum, and that value of U minimum you have to compare with the tabulated value of Mann-Whitney U. So very simple. This will do tomorrow, and finally I will let you know that how to calculate the p-value exactly after seeing the table by using the formula, the calculation of p-value. For example, once we have got a value from the table, for example, we have got this value, I'll let you know. Our calculated value is 56. Our calculated value is 56 and tabulated value is 69. 69 we have taken from the table. So how to get exact p-value? For that we need a calculation. This is the calculation. First of all, we have to calculate the z-score, that means the distribution, normal distribution. Then from the z-score we can calculate the p-value. This we will see, and how to apply the Mann-Whitney U test with the help of SPSS, and how we have entered the data. Like this, you can enter the data. As you can see on the screen, the waiting time has been entered in terms of minute. Like this, we have entered the waiting time, and type of clinics will be separately. We are not going to make. Type of clinic will be a single variable in this one, like patient number 1 who visited to medical ward, patient number 2 visited to surgical ward, patient number 3 visited to surgical ward, patient number 4 visited to medical ward. Like this is in a single column. You should write that either A or either B. You should not make that here you're writing all the medical ward patient and here you're writing all the surgical ward. And if you have a 3 level of specialty and you are going to make a 3 different column, one for primary, one for specialist, and one for tertiary, so that is wrong. Just only one column will be made, and under that one column you have to choose the option. So what we'll do in SPSS, we will categorize. We'll give a code 0 to medical and code 1 to surgical, or you can give a code 1 to surgical and code 2 to medical. So you have an option 0 or 1 or 1 or 2. So any one of them you can use. And for the same, to specialist you have to give a code 1, to tertiary you have to give a code 2, and to primary you have to give a code 3 under the value label. So once code has been entered, so data will be entered in terms of code. So as you will switch the view, you are going to see that here it has been written 1 1 1 1 2 2 2 3 3 3 like this for medical and for label. And for applying the Mann-Whitney U test, I'm going to use this one, clinic versus waiting time for Mann-Whitney U, because here we have a two categorical variable, and one is the numeric variable as a waiting time. And to apply a critical volleys, I'm not going to use a clinics. I'm going to use a 3 categories where we have in super specialty, that is primary, specialist, and tertiary. So this versus this, I'm going to apply for a critical volleys test, and medical ward and surgical ward will apply Mann-Whitney U. So 2 tests will be applied with the same data. So any doubt, if anyone is having, I'm ready to take the queries. I'll just switch to the view. I'll see in the chat box we have anything. Okay, no queries. Yes, so if you have anyone, you can ask, so that I'll answer the queries or I'll finish the session.